So, a couple weeks ago, you may remember that Calla horribly abandoned me. So, today, we are going to punish her. This here is Her Majesty, and she will be judging the proceedings to see if the punishments are severe enough. Child, we punish you for abandoning us in a deep, dark time of need. And now is the proclaiming of the punishment. Calla, you must give an in-depth explanation of hybridized bonds while drawing a picture with your toes of a penguin. You are explaining hybridized bonding.
Oh, the horror!
It's quite peculiar. Very odd, I admit. And chemistry is sad and confusing, even though they like it. I don't understand this. I approve.
I want that one.
Uncap it.
So, world, there are these things called atoms. Oh no. And there are also these things called electrons. And the electrons are, generally speaking, probably around the atoms most of the time. And there are regions around the atoms where an electron is more or less likely to be. And the regions where certain electrons are more likely to be are called orbitals. This is really hard. So for instance, if you take a hydrogen atom, which is the most simple of all atoms, I can't even pick up the marker in a way that makes sense. Ah, I got it. If you take a hydrogen atom, which is the most simple of all atoms, wow, this is hard, and you look at its electrons, it only actually has one, because it's really, really super simple and stuff. And that electron's orbital, or the space it is most likely to occupy, is in a spherical, generally speaking, formation around the nucleus of that atom. And the nucleus is where all the other interesting parts of atoms are. This is really hard. So,
Hello.
the orbital of hydrogen is a sphere. And it looks like this. I'm just gonna break the rules for a minute and sort of try and draw this. So nucleus, orbital of hydrogen's electron, that's supposed to be a sphere, YouTube.
Well, it looks kind of like the electron cloud.
Yeah, see? They're also called electron clouds. And yeah, that's what an orbital is. And some of them are funky shaped. Like if you get p orbitals, which are just a different shape of orbital, they go up. Oh, I don't have space. I'm drawing on newspaper.
I'm giving you another color.
They go up and around. I have to color it in. No, I don't want that. That's not the penguin color. You have to give it a darker color.
Okay, I'll give you this pathetic little marker.
No!
I'll even uncap it for you.
Ooh, give me green. P orbitals look like those outside squiggly things, and then sometimes there's even a Z level p orbital, which is weird and hard to explain, but it's this one's coming out at me and this one's going back. And then you get into some really weird funky ones when you get to the d orbitals, because there's one that looks like this. It's a giant loop-de-loop, and this is basically just more outer levels of electrons. And they go like this, and they go like this. This is d, this is like way far out there. And then there's a loop around that, which is weird because it's shapy, and thankfully I don't have to know most of this.
It's weird because it's shapy.
That looks like a small child's drawing. This is really sad. This reminds me of the polar graphs that we're drawing right now, the shapes of
Yeah, it does.
electrons.
A lot.
Yeah, actually you could probably graph them pretty easily. I wonder if there are 3D polar. That would be
so fun.
Awesome! Now we're getting nerdy and weird, but yeah, that's basically what an electron orbital is. It is the space in which an electron is most likely to be, and they have various shapes depending on their designated letter, so to speak. And what else is there about electrons? Oh, the reason they're more likely to be there is because they don't just sit there. They move all the time, and sometimes, technically speaking, there is a very, 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 very small probability that an electron could be like all the way over here, YouTube. This is the nucleus. There is a tiny, tiny, tiny probability that the electron could be 10 feet away from it. They're just more likely to be in this general area. And the more in the middle of that area it is, the more likely the electron is to be there. No! Mr. Oh, okay. Can I have a yellow now? Because I need to
You
show.
can uncap a yellow. Contain this.
Get your. Ow! Oh, that hurts. Okay. Okay, somebody's got to do this. Come on. It hurts. So he's getting a yellow beak now. If I can make this marker work, and I don't think I can. Nope, it's a crappy marker. This is really hard!
Calla, get your hand out of there.
But it's still...
Yeah, it can have a blue beak.
Where did the lid go?
I don't know.
A blue beak and a blue belly. That's what's gonna
Try and move the lid.
I don't know. Ow! Please. There, I got it. This is really, really hard, okay? Specificity is not my strong point when drawing with my toes.
I want to see the bottom of your toes.
One time I painted a jellyfish with my toes.
Ah!
Not
My feet.
I should draw him pink.
Wait. I have to write something awesome.
What is that thing on its butt?
It's a tail! No.
What are you trying to write?
Just trying to write her signature.
The.
Okay, because why? Oh, she's shading the end.
Oh, I see.
Exclamation mark.
Oh, Calla, haven't you done enough?
Be proud of me, YouTube, for I am punished.
341 419 2653 5 3 2 3 4 6 4 3 3 8 3 2 9 5 2 8 8 4 1 1 6 7 I could continue because I have 100, but that would kind of bore you because you're probably not as nerdy as I am and don't enjoy memorizing pi for fun. I didn't even do it for extra credit. Okay, would you? The end.
Hi!
The end. It's Pi Day Friday. Bye.